Okay, so let's do that. Okay, so what we first need to do is to make a right triangle where this is true. Where this is true. Where tangent of theta is 2/5. That's what we need to do first. So remember, tangent of theta by SOHCAHTOA is opposite over adjacent, okay? And in this case, it's 2/5. Here's our right triangle. This is from the previous slide I put here for convenience. Now, what we can do for this triangle, for this to happen, for tangent of theta to be 2/5, we can set the opposite side to be 2 and the adjacent side to be 5. So the opposite side is 2, adjacent side is 5. We can do that. And that's what I do actually. Because if I do that, then we have this right triangle. And really just looking at this right triangle, we can say, oh yeah, well, tangent of theta is opposite over adjacent, like so. And that happens. Good, so that's good. Okay, that's awesome. So that's what happens here. But we don't know what the hypotenuse is. I'm going to call that x just for convenience, but we don't know what this side is. Well, can we find it? Well, yeah, we can. How do we do that? Pythagorean's theorem. Pythagorean's theorem, right? For a right triangle with Pythagorean's theorem, if you know 2 of the sides, you can always get the third side. And that's what I'm doing here. I called it x. So by Pythagorean's theorem, we have a squared plus b squared is c squared. So in this case, we have 2 squared plus 5 squared is x squared. And we get this. Okay? So we have x squared, right, equals 2 squared plus 5 squared. Okay, well, 2 squared we know is 4. 5 squared is 25. X squared, right, is equal to the sum. So x squared is 29, and x is square root of 29. Okay, so x is the square root of 29. So that's our third side. That's the hypotenuse. Remember, the hypotenuse is always opposite the 90-degree angle. Okay, I forgot to say it, but I'll say it here. Opposite, OPP, that's opposite theta. Adjacent is the side next to, adjacent to theta. I forgot to say that, although we have seen this stuff before, so I guess that's okay. But now that we know all 3 sides, we're in business, basically. Because now we can easily get all the trig functions. Right? We just have to use the definitions. You know, here sine is opposite over hypotenuse, which is 2 over radical 29. Cosine is adjacent over hypotenuse, which is 5 over radical 29. And we have tangent already. Remember, let me just say it quickly because we're running low on time. When you have 1 over sine, you just flip whatever sine is. So sine in this case was 2 over radical 29. You just invert it. So you get radical 29 over 2. And that's what we get here. All right, we're actually out of time. So I would recommend you look this over and make sure you understand it. And we'll do some more trig next time as well. Okay? All right. So if